Hi guys, welcome to SparkFun Education's video about how to use Scratch and PicoBoard sensors in order to make a really basic game. So what you're going to need today, a PicoBoard, which looks like this. Then we've got our analog input gator clips. They plug into the PicoBoard down here on A, B, C, and D. You'll also need a USB to mini. You're going to want to plug the small side into your PicoBoard. And then the large side, goes into my USB connection on my computer. I can go to scratch.mit.edu. Downloading Scratch is right here. It's this brown button. If we want to look at where exactly our PicoBoard is plugged in, what I can do is on a PC, I would go to my control panels. I would want to go to System and Device Manager finally. If I've already installed my FTDI drivers, I can look under ports and I should see a USB serial port other than COM port 1. In this case, it's COM 6. An easy way to check to see if this is indeed the device that's plugged in is I can just simply unplug my device. I'll see a refresh in my device manager, and I can go down, and through process of elimination, I know that COM 6 is now missing. So I know that this is indeed COM 6. So before we actually jump into Scratch, I'd like to talk about the PicoBoard real quick and exactly what's going on here. So we've got our USB connection over here, and then there is an Atmega chip on here, but the PicoBoard doesn't actually supply any output from the Atmega chip. It's entirely input that it then ports through the USB cord into Scratch. So the sensors that it is porting are predominantly analog, but there is one digital push button. So we've got a digital push button that's just on or off, and this has its own distinct Scratch code block. And then for the analog sensors, we've got a light sensor that has a little eye around it right there. We've got our slide, or our potentiometer, here. We've got a microphone down here, and various places you can plug in analog sensors. So all of these sensors send values from 0 to 100. If you're used to working with an Arduino and a regular Atmega setup, the analog sensors go up to 1023. But because this is an introductory system, we want to be able to give people just 0 to 100. The first thing you should notice when you open up Scratch is that we've got 3 different distinct areas. So you've got over here, you've got your code blocks and your libraries. There are 8 different sort of distinct libraries that all contain blocks of code that are pertinent to certain aspects of your sprite. So for example, this is motion. So these are things about how I can actually move my sprite, turn my sprite, maybe make him go to a particular X and Y location. Next to that, over to the right, we've got control. This is where you're actually going to control the logic flow. Over here, we've got looks. This is dedicated to controlling exactly how your sprite looks. Next to that, we've got sensing. This is where you can ask your sprite sort of conditionals. If it's touching a color, if it's at a particular X position, if it's touching another sprite, if there's a button click or any keyboard buttons pressed, how far away your sprite is from other sprites. And most importantly for us, these 2 blocks at the bottom here are how you're actually going to check up on the slider sensor value or the button, if the button has been pressed. Over here we've got sound. You can actually record your own sounds. Next to that we've got operators. So operators is really where you're going to do any and all math, so checking multiple conditions or checking the negative of a condition, a not. Over here we've got pen. The pen is dedicated to making your sprites draw. This is useful, for example, if you're driving a car in a game and your car goes off the road and you want to draw some dirt tracks that your car is leaving. And then last but not least, we've got variables right here. This is great because variables are one of the formulative skills or formulative ideas when it comes to computer programming. So we can actually make a variable or make a list. And this is going to be used to store any information. And we're going to be doing that as well. In order to actually grab blocks of code, what you can simply do is grab one of these guys and drag them onto here. As you just saw, if you right-click, you can actually find a help menu for any of these blocks of code. That's going to be incredibly useful. You can use an infinite amount of these blocks, as many as you want. To delete them, you can right-click and delete. To duplicate, right-click and duplicate, or you can even drag them over here back into the library code in order to get rid of them. Next up in the middle here, we have sort of our sprite control area. This is where we're going to be adding scripts. We've also got costumes. We also have sounds over here. We can import existing sounds or record sounds. You can play sounds to see what they sound like. You can't use the microphone on the Pico board in order to record sounds. And then up here we've got places where I could name my sprite. So maybe I want my sprite to be Spark Funyun. These three radio buttons over on the left are how you can actually control the rotation of your sprite. So for example, right now my sprite has the ability to rotate 360 degrees on an axis, and it actually changes the image. So as you can see, my cat is sort of tilting down and to the right a little bit. But I can change that if I click on the one below, and now my cat will only face left or right. This top button is good for top-down view games. This stop button makes it so that you can't rotate the sprite at all. Other than that, you can get X and Y coordinates up here. And then we also have the direction that it's pointing. These directions are in degrees. Other ways you can control the sprite are these four buttons. If I want to duplicate my sprite, I could actually stamp on this guy. It actually creates a duplicate sprite both on my stage here as well as down in my sort of sprite listing area. Next to that, we've got a delete. So if I wanted to delete my sprite, I could just click on it. I've got the ability to make my sprite grow with this button. And then next to that, I've got the ability to make my sprite shrink. Over to the right of those four buttons, we've got our various presentation modes. This is the small stage view, where we have a small stage view. You're gonna use this if you're gonna want to do a lot of programming. And we've got large stage view. This is good if you're just doing a little bit of programming, or if you're doing some game testing, but you still want to be able to see your programming. Then there's presentation mode, which basically isolates your stage. And this is how you would actually present your projects to maybe your classroom. This is also what your project is going to look like when it's displayed on the Scratch website. Below that, we've got our start green flag scripts. So we're going to be writing scripts that use the green flag. And basically, this is kind of like a start your game button. And next to that, we've got a stop everything button. You can actually see it's giving me a live indication of my X and Y coordinates of my mouse. Scratch works in a Cartesian graphing coordinate system, with 0, 0 being the center point. Then down here, we've got ways to manipulate the sprites. So we can paint a brand new sprite starting from scratch. If I click on that, it gives me a paint editor that should be pretty familiar to just about everybody. We've got choose new sprite from file. So you guys can actually download sprites from the Scratch website with pre-existing scripts on them, or you can choose from their examples. We're going to do that later. Or, and I like this button a lot, get surprise sprite. So this just randomly picks a sprite and throws it up on your stage. Speaking of your stage, you've also got the stage itself. You can place scripts on your stage. You can draw different backgrounds. I could make the mountains be my background, or I could have the pyramids be my background. I can either paint, again with my familiar looking interface there, or I could import JPEGs, GIFs, SVGs, PNGs. Once you have your images down here, you can actually further edit them. So if I was to import that image, I could go back in and take out the background. I feel like everything's pretty obvious with the exception of our set language button over here. You can actually set the Scratch language to a whole bunch of different languages. Two buttons over from that, we've got this orange button called Share This Project. If you have a connection to the internet, this will actually automatically upload your project to the Scratch website. It will ask you to log into Scratch if you're not already logged in. So you will need to create a user and password and all that stuff. So the first thing we're going to do is we're going to go into our sprite and we're going to edit the costume. So again, I clicked on my sprite down here, my managing area. I went up here and I looked at costumes because we're changing how he looks. If I was concerned about editing this costume and keeping an original copy, I could just hit the copy button and it created a costume number 3, which is an exact duplicate of costume number 1. But that way I could go in and edit this costume and I would still have the original here. So I'm going to go in and edit this guy really quick. I'm going to use the fill tool and a gradient tool, and I'm going to make this guy purple. So I need to make sure I get all of the orange. So I'm going to hit OK and save my changes. So one important thing to note about animation is that if I now switch between these two costumes, which is what my code is going to be doing in the future, it looks pretty strange to have the two costumes be different colors. I apologize. So I'm going to go in and I'm going to edit this guy as well. So you want to be careful when you're playing around with this Set Costume Center option down here. What it does is when you click on this plus, it creates a crosshair for you. This is the default positioning. So if I wanted to, I could actually make my center point be this guy's toe. And that way, whenever he rotates, he's going to rotate on his toe, which might be cool for maybe making him jump and stuff. What we got to remember is I've changed this registration point on this costume. I didn't change it on the other costume. If I were to save this and I were to go back to the other costume, I'm going to see my character jumping because the registrations are at different areas. So if you change the registration point in one costume, you need to make sure that it corresponds to all the other costumes. All right, so I've come into scripts here by clicking on the scripts tab, and I'm going to start making some code for my sprite. So the first thing I'm going to do is I'm going to go to the control library section of my code. Again, that's the orange section, so I just click on control and it gives me all these options. So what we're going to do is we're going to grab the when green flag is clicked to make our first piece of code. What this does is this starts any code that's connected to this block. It starts that code whenever we click on the green flag. And now I need a way to make my code continue to happen after I click the green flag. So we're going to do that with a forever loop. If we didn't have the forever loop, it would just run my code once, and then it would not run the code again. So that's great if you just have an intro animation, but it's not good if you want gameplay to go on for as long as your user is interacting with your Scratch project. So we've got a forever loop here. I just dragged it out, and you can see that white bar appears when I'm actually docking this. You can't just place this guy here and hope that they'll actually function. It will show you when it's docking correctly and snap to it. In order to move the blocks of code, often you'll have to make sure that you're clicking on places where there isn't any, where there aren't any variables or any text most of the time. In order to undock, what you'll need to do is, if there was code inside of my forever, I would have to pull this guy away from here maybe, pull the code out from it, and then play with this, and then reattach it. So I've got my forever loop here. We're going to go into motion, so it's upper left, blue blocks, and we're just going to have him move 10 steps. When I click on my green flag, I'm going to make this big so you guys can see what's going on. When I click on my green flag, he's just going to move forward 10 steps forever. He kind of went off the screen there. So the first thing I'm going to do is I'm going to use this little go-to X and Y positioning to reposition my character to the very middle of the screen every single time I press my green flag. When I drag that in there, because we have the white bar in between when green flag is clicked and forever, it'll automatically insert that in there. And then any of these fields that are white fields, you can just enter a different number and you can change that variable. So now what happens when I click my green flag is my guy goes back to the very center, then he starts moving over to the right. So if I want him to move faster, I can change this number 10 to a higher number. If I want him to move slower, which I do, I'm going to change it to a 2. So the next thing we are going to do is we're going to make him bounce off of the edge. So we're going to go to sensing, which is just below control. And we are going to find touching. And if we click on that little arrow, we can see that we can make stuff happen when he's touching either the mouse pointer or the edge. So in this case, we want to make something happen when he's touching the edge. So I'm going to select edge. So right now, our forever loop is pretty boring because he just goes the same direction all the time. But now, we're going to go into control. And we're going to find our if statement. So we're just going to drag an if out, and we're going to put it below the move 2 steps. So it's now inside of the forever, below move 2 steps. And you can see if has a place for a blank conditional. It looks like a hexagon. And look, our touching the edge block is a hexagon. So in this case, we know Scratch is actually indicating to us what kind of blocks of code can actually fit in here. So anything with a rounded edge will not fit in here, but the hexagonal will fit in there. So I can just drop that guy in there. So now when my code comes through, after I click the green flag, it's going to set my guy's position to the center. And then forever, it's going to tell him to move forward 2 steps. And then it's going to check, and it's going to say, hey, wait, we got to ask a question real quick. And the question is the guy touching the edge of the screen? What do we want to have happen if he's touching the edge of the screen in order to make him bounce back? We're going to change direction. Any ideas where changing direction might be, guys? In motion, exactly. So I'm going to go back to motion, and I'm going to tell it that we want it to turn 180 degrees. But apparently this is a block of code that is used so much that they boiled it down to 1 block of code. So we could just put that below the move 2 steps. So let's see what happens now when we click on this. So he's moving towards the screen, and now he bounces off of the screen. If you do want to add comments so that people can follow along what's going on with your code, you can actually right-click next to your code, and you can tell it to add a comment. Maybe I want to add a comment that says, this code deals with movement. OK, so this is cool. We've got our guy moving around. But I want to be able to control the guy moving around using my sensors, right? That's the whole point of the Pico board. So what we're going to do is we're going to replace this forever loop that we've got with a forever if. So I came to control, and I have to scroll down a little bit. And forever if looks very, very similar to forever. It's just got an if thrown in there with it. So I'm going to place it below my code. I'm going to drag my code, blocks of code that are inside the forever, and put them inside my new forever if. And then I'm going to get rid of forever. I'm going to pull this up so that it's now part of my code. And I'm going to go to sensing, because I want this code to occur whenever I press my button. And I'm gliding my slider button pressed block. So you can notice this is that hexagonal block that I was talking about. If you look at the other values, the other slider values, because they're not digital, because they're analog and it's not, these can't answer a simple yes or no question like an if statement, they're rounded edge. So these are variables. These are number variables from 0 to 100, whereas the hexagonal is just a yes or no. So that's why I can't actually place this inside of my if statement. So I'm going to come back, and I'm going to place my sensor button pressed inside of my forever if. But now what's happening is that when I click that green flag, my character doesn't move unless I'm pressing and holding down the sensor button. So what we're going to do is we are going to go back to our motion, and we are going to tell him that we want to point in a certain direction. So I'm going to grab this point in direction. 90 degrees is the 4th block of code down. And I'm going to just drag that and place it at the very top before he moves inside of my forever if. So right now it's always making him point in the direction of 90. So this has a drag down. I can make him point right, left, up, and down. So right now he just automatically, when I press the button, he's going to the right. I could, however, I could use the drop down to make him go up, down, left, or right. Or if I wanted to put maybe a 45-degree angle in there, I can use my keyboard to put 45 degrees in there. So now whenever I'm pressing the button, he goes up or right. But I want to be able to control him. So what I'm going to do is I'm going to replace this variable with our slider. So I'm going down here to sensing, my sensing library code, and I'm going to grab slider sensor value. And that drops right in there. I'm going to move this over so you guys can see it. So now it's pointing in the direction of the slider sensor value. So let's see what this does. So when I start this guy up, I'm now able to control my dude to a certain extent. Unfortunately, he tends to get stuck in the upper right-hand corner. So the reason for this is because my sensor values on my Pico board only go from 0 to 100. However, our world in a 2D environment has 360 degrees that we can move in. So we need to do a little bit of math in order to map the 0 to 100 value to 0 to 360 degrees. So obviously, operators is what we're going to use to do the math. That's the green blocks, and it's right below sensing. So I'm just going to take this slider guy out of my point and direction block, because I'm going to need to add various things to it. So the first thing I'm going to do is I'm going to get this down to a decimal value. So I'm going to divide my slider value using a division block in operators. Again, it's the fourth block down in operators. So I put the slider sensor value in the first variable space, and now I'm going to click in the second space, and I'm going to type 100. What this is doing is I'm now dividing whatever number, any number in between 0 and 100 being sent from the slider, I'm now dividing it by 100 to get it down to decimal value range. So it's now a number in between 0 and 1. So then what I can do is I can grab my multiplication block, that's the third one down in operators, and I can now multiply. And again, watch this, guys. If I try to grab, you got to be really careful where you're grabbing your blocks. Because if I want to grab my entire block to move it where I can see, if I just grab the blue block, it'll actually pull that out of there. So I need to make sure I'm going all the way over on the left and grabbing the outermost block, or all the way over on the right. If I click on any of these symbols, it'll do things like giving me the results, or in some cases it'll actually allow me to change. If I right click on them, it'll allow me to change these from a division to a multiplication. So I'm going to multiply this by 360. So some of you guys are watching this and going, hey Lindsay, why didn't you just multiply by 3.6? I agree entirely, but I just wanted to do this to show you guys all of the steps that I'm going through in order to make it really, really obvious exactly how we control our characters. So now that I've done that math, and you guys who are familiar with Arduino may be looking at this and seeing this corresponds to the map function, MAP, map function in Arduino. I'm going to go ahead and pop that guy right back into my point in direction. I can scroll over to see the rest of my code. And let's see if that works. So I'm going to hit my green flag, puts my guy in the middle. And now, look at that. I can control all 360 degrees. This is really cool, but we're not utilizing the animation that's inherent in Scratch. So what I'm going to do is I'm actually going to make a walk cycle. I'm going to make my guy look like he's walking, because we've got two costumes here. And if we switch back and forth between them quickly, makes him look like he's walking. So I'm going to come back to my scripts here, and I'm going to go into looks. We haven't used looks yet. It's the purple blocks just below motion. And I'm just going to tell it, because we only have two costumes, what I can do is I can just tell it to switch to the next costume every time that it completes a forever loop. So I'm going to grab the second block down, next costume, and I'm going to put that at the very bottom of my code. So now I'm going to stop everything and start everything again, and we're going to check to see what this looks like. So this is pretty cool, but my guy runs pretty quick, huh? I'm going to go to Control. I'm going to grab Wait. My Wait block is my fourth block down, and I'm going to put him under next costume, and I'm going to tell him not to wait 1 second, because that's going to make it really slow, but I'm going to change this to wait 0.1 seconds. So now, after it does all this code inside of my forever loop, it tells it, hey, just wait for 0.1 seconds before continuing on. So now it's really starting to look like my guy is wandering around. Next move, we're going to add a sprite. So we're going to come over here to our sprite control area, just below our stage. You can either choose your new sprite from a file, or you can get a surprise sprite. I'm going to walk you guys through choosing a sprite from a file real quick. So I click on that button, and I'm going to go into Fantasies. I'm going to grab a troll as my bad guy. I'm going to go ahead and put this troll on here. I don't like my troll being a lot bigger than my good guy, so I'm going to shrink him down a little bit using the button up here. So let's look at my troll costume. So I've just got the one image, but I want to have my bad guy turn into something whenever my good guy touches him. What I can do is I'm going to import a new costume, and I need to find something that I like as an image of what my troll guy changes into. We could do things like we could change him into a bowl of Cheesy Puffs, or we can copy the existing troll and we can edit him. I'm going to make his hair start to change to Cheesy Puffs. So this is how we can start incorporating animation into what we're doing here. And I'm going to make his fingernails change into Cheesy Puffs. So he's now starting to have Cheesy Puffs sort of occurring. And I could hit OK, and then I could copy this one, go back in it and edit it a little bit more, and now he's really starting to turn into a Cheesy Puff guy. So, oh, wrong color. So I'm going to go in here and do my undo. So now we've got cheesy puffs all over our troll. This is kind of showing you how you start to do animation. So now my costume, I'm going to switch from this one to this one to this one to that one. So I've got my costumes. I need to come back to sprites. You guys should be familiar with this by now, but we're coming back to control. We want this guy's code to be happening, to start happen whenever we click on the green button. So we're grabbing a when the green flag is clicked control. We want to always be checking to see if the troll gets hit by the good guy. So we're going to need to have a forever loop in here. Next, what we want to do is inside of my forever, and I could have used a forever if, but I'm going to use a if. And now what we want to do is we want to sense, so we're going back to sensing. We want to sense to see if my troll is touching my Spark Funyun sprite. So I grabbed touching from sensing, I put it inside of my if. I went to my scroll down and I grabbed Spark Funyun as a sprite to check to see if it's touching. And now we're going to do our animation of making him change into Cheesy Puffs. The original costume that he's going to be is the troll. I want to change what he looks like. So I'm going to looks, and I'm going to tell it if it's touching the Spark Funyun, what I want to do is I want to tell it to switch the costume. And I know I wanted to switch the costume a bunch of times, so I'm going to grab a couple of these. First thing I want to do is I want to tell it to switch costume to troll number 2. Because if we look back at our costumes, that's the troll where he starts to grow cheesy poofs. So he switches to troll number 2. So what would happen, guys, if I immediately just made him switch to costume troll number 3? Would not work, right? You wouldn't actually be able to see troll number 2 because the computer moves so quickly. So again, we got to come back to control. We're going to go down here and we're going to find our wait. We're going to tell it we want to wait a half a second. And we're going to do that after each time we switch our costume. And finally, so these two, troll 2 and troll 3, are animations of him growing cheesy puffs. Finally, we've got our cheesy puffs that he changes into down there. I suggest doing basic animation for stuff like this and then going back and adding animation later. Because it's really, really easy to get bogged down in just making an animation and never really making your game work. So it's really good, especially with students, to have them do an animation with 1 or 2 costumes and then encourage them to move on and really come back to that as sort of a reward for creating other aspects of your program. So I'm going to go over here and I'm going to run into my troll. Oh, he's growing cheesy puffs, and he turned into a cheesy puff. But he turns into a cheesy puff and he never changes back into the troll. I'm going to go into my code here and I'm going to add one more switch to costume and one more wait. So now I'm going to tell him to wait 2 seconds and then switch back to the costume of the troll. So now when I start my code, when I run into this guy, he grows cheesy puffs, changes into the cheesy puffs, and then back into the troll so I can run into him again. So at this point, I'm actually going to go up and I'm going to save my project. Commenting, like we did on this guy on Spark Funyun right here, and using the save as are 2 of the most important skills that a beginning programmer can pick up. So I'm going to go to File and Save As. I don't want to save because that's just going to save over my old file. And I won't be able to tell the difference between the changes that I just made and the changes and the code that existed before that. So if I worked forever, I'm making a whole bunch of new code for my troll, and then I saved over my old version, and then I found out when I tested it that my code is broken, I wouldn't have any reference point. I couldn't go back and look at my old file. That's why we use Save As. So for example, this is Spark Funyun 01. I could put in my project author. So this is by Linz Craig. And down here about this project, this is a project used to teach Scratch and PicoBoard basics. I encourage you guys putting in your author and a little about the project in here, because this is what shows up when you share your project on the Scratch website. You want people to know who built it so they can attribute it to you, which is a key part of open source project creation. So I'm going to go ahead and save this. Now we're going to make our Spark Funyun sprite. We are going to make what's called a whole different thread that makes it so that the size of the cat depends on the light sensor. And we're going to do this, we're going to only make the size change when we click on the cat. So I'm going to go in here to control. So I clicked on my cat, my SparkFunyon sprite. I went into scripts. Now I'm going to go into control, and I'm going to say, hey, I want to have code that occurs when I click on this sprite. So I'm grabbing a whole new way to start code. So it's the third one down. It says when SparkFunyon clicked. So I just dragged that into my scripts area down here. What I'm going to do is I'm going to tell it that I want to change how it looks. We're going to set the size of my cat whenever we click on it. So I grab set size inside of looks, and we're going to change the 100% to whatever our current light sensor is. So in order to get the light sensor, we need to grab the slider sensor value block. I'm putting it inside of that variable field, and I click on the little triangle, and here's how I can actually select which sensor I'm talking to. So I'm going to use light to control the size, but you guys should feel free to use sound or even the resistance A, B, and C, and D. So those are sensors you can plug in. The Pico board doesn't currently support tilt and distance, which are down here, but those are things that are coming. And now we don't need to put this in a forever loop because we really only want this code to occur whenever we click on our guy. Now we can actually test to see if this works. So you don't actually have to click on your green flag because this code right here doesn't depend on the green flag. So we can actually test this by covering our sensor and clicking on this guy. And he gets really, really small if my light is completely covered. And he gets really hard to click on. Another cool thing is what I can do in here, if I decide that he's getting way too small, I can go into my operators and I can use a multiplication just to multiply this light sensor value by 2. So now he's just going to be twice the size that he regularly was. So that's one great way that you can change. And I know we did that before in point and direction, but I just wanted to point out that you can always manipulate these sensor data values. Now when I click on this guy, he gets kind of large. Next thing we're going to do is we're going to add a variable in order to keep score. So we're going to go to the variable section down here below operators. We're going to click on make a variable. This variable name, I'm going to name it score. And then below here, we have a place where we can select the scope of this variable. So scope is very important. What scope means is it means where I could actually use this variable. A lot of times people limit the scope of a variable in order to save memory because it takes more memory in order to make a variable that's accessible at all levels of your program. So they give us the ability to make this a global variable, which means that it can be used in all sprites anywhere in my Scratch project. Or we can make a local variable and click on for this sprite only. However, that means that we will only be able to reference this variable in this sprite. So for example, if I made score for this sprite only, I would not be able to control the background image depending on my score. So a lot of times you'll see the background image change. Maybe if my score goes above 10, I know that I'm going to a new level. So I'm changing my background image from maybe the mountains of Denver to the pyramids in Cairo, for example. I wouldn't be able to do that if this was local only because I wouldn't be able to talk to the score variable from my stage background image. So I'm going to choose for all sprites. And you can notice it shows up in the upper left-hand corner here. Another thing we can do is if you look over here now in our library section, we've got a whole bunch of options that show up whenever we have made a variable. We can actually now delete a variable. We can make it show up on our stage or not. If you look over in the right-hand corner, when I click on this, it shows up and disappears. And that's actually something you can control dynamically from inside the code. Below that, we've got set score to any number, change score by any number, and we can change these to either a positive or a negative number. And these are below that, we've got show and hide the variable. So the first thing I want to do is I want to set my score to 0 anytime we start a new game by clicking on the green flag. So I'm grabbing set score to 0, and I'm placing it above go to x 0 and y 0. So this little section above our forever loop, this is kind of like our setup. This is stuff that's going to happen whenever we start the game, and only once, because it's not inside of our forever loop. So now we set score to 0. But we also need, we need to be able to up our score. So what I want is I'm going to go into sprite number 1, our bad guy, and every single time our good guy touches our bad guy, I'm going to change score by 100. So I'm going to go in here, and I'm actually going to test this out, and we're going to see if this works. So I'm going to run into my troll. Bam! He's changing into Cheesy Puff. I got 100 points for that. Bam! He's Cheesy Puffs again. 200 points! I am just winning this game. Let's see now if our stop and our setup function works. Yep, we know our setup function works because our score went back to 0. And our guy returned back to the center point. So I've made enough headway that I'm going to go down and I'm going to save as again. I want to save it as number 2 because again, guys, I want to be able to compare it to my old code. Maybe I put something in about the project about how it changed. Another thing I want to point out, if we go into File, we could actually export individual sprites. So maybe I like my animation on this troll so much, and there's 2 places we can do this, that I want to export this sprite. It'll export the costumes and all of the scripts on my sprite. So that's a great way to be able to share good guys and bad guys among all of your friends. So the next thing we're going to be doing is we are going to add a maze. I'm going to make a really, really simple maze just to show you guys the basics. I encourage you guys to play around with making a really, really complicated maze. You will have to use different values on how far your character moves, because depending on the width of the walls of your maze and the width of sort of the channels of your maze, you don't want your character to be able to hop over the walls of the maze, obviously. In order to create that maze, I'm going to click on Stage down here, and I'm going to go into Backgrounds, the Backgrounds tab, and I'm going to edit my background. So you can make a maze elsewhere, say in Draw or Adobe Illustrator, or help me out, what's the open source one? GIMP or Inkscape? Yeah. And then you could import it, but I'm just going to make a really easy one by editing. I'm going to go over here, I'm going to grab a line tool. I'm going to change my brush size so I have slightly thicker walls for my maze. And then I'm going to choose a color that is not already in my sprites. Your code is actually going to be checking depending on the color of the pixels. So you don't want to use a color for your maze because you're going to be putting code that makes your sprite do certain things depending on if it's touching the color of the walls of your maze. But if that color is also in one of the costumes for your sprite, then whenever you touch that sprite, it's going to act as though it had touched the wall. So I'm going to use bright red because we haven't really seen that yet in any of our characters. It's going to go from the top down to here, over to here. Bam! That's my maze. So I'm going to press OK now. And I'm going to go ahead and I'm going to situate my troll down here. And again, I'm going to make my troll a little bit smaller so he fits inside of my maze. Because he's not doing anything now, but I could conceivably make code so that my troll wanders around and bounces off the walls of the maze. Now that I've got my absolutely beautiful maze, I need to go back to my good guy. And I need to go back to my good guy script. So I've gone to my script tab in my SparkFunyun sprite. I'm going to make yet another thread. So I'm going to go up into Control, and I'm going to grab another when green flag is clicked. So this is a whole new set of code that's going to occur independently of this other code whenever we click on the green flag. So what we want is we want forever. We want our guy checking to see if he's touching the maze. So we're going to go into sensing, and we're going to see if he's touching a particular color. And I'm going to go back into Control, and I'm going to find an if. And I could have done this with a forever if, but maybe I'm thinking down the line and I'm thinking that I want to put other stuff inside of this forever. And so I'm going to grab this touching color, I'm going to put it inside of if, and when I click on the color right here, it gives me a little eyedrop color, and that I can use to go over here and select the actual color of my maze walls. So now I'm making code happen anytime that the sprite touches the color red. And what I'm going to tell it to do, it needs to turn around. I am going to use my existing code. So I'm going to take this move 2 steps, if on edge bounce, next costume, and wait, away from my point and direction slider code. So I grabbed this guy from here, and I pulled it down here. Next, what I'm going to do is that allows me to grab just this little piece of code right here. I'm taking it out of my forever if, and I'm dropping it down here so it's not touching anything. Now I'm going to right-click on the point and direction, and I'm going to tell it to duplicate. So now I've just duplicated all of that code. I don't need to do it again. I'm going to put the original code back where it was. But now I've got a new point and direction code that looks exactly like my old one. But we don't want to point in the same direction whenever we hit the wall. We want to make him move in the exact opposite direction that he went. So what I'm going to do, I'm going to put it inside of my if statement, and I'm going to change it so it multiplies by -360. So now this code out here says, okay, when we click on the green flag, forever, always, I want you always to be checking to see if we hit the wall. So if we're touching the color red, meaning we've hit the wall, I want you to immediately point in the opposite direction, 180 degrees of the direction that I'm pointing in right now. And I'm going to have you move exactly the exact opposite of how we just moved. So I have to go up here and look inside of my movement code, and I say, oh, I move 2 steps at a time. So I'm going to change this so that it moves 2 steps instead of 10 steps. The reason for that, guys, is you may say, hey, I wanted him to move 10 steps because whenever he bumps into the wall, I want him to back up further than he moved forward. But what happens if there's a wall on the other side of your wall? When he bumps into the wall, you don't want him to move backwards farther than he moved forward the last time it went through our loops, because then he could conceivably jump across a wall on the other side. So we just want him to move back 2 steps. So now I'm going to go ahead and, my favorite part, testing my code. I'm going to start green flag scripts, and now I'm going to make my guy run into the wall. Uh-oh, that's not working very well. Sorry, it wasn't -360. We should be multiplying it by 180. So now, when I click on this and I make him jump into the wall, and there's some issues. I'm going to have to clean this up. But he's basically going, and that's the problem with this. We're going to need to make some more complex code. But if we look at this, he kind of, it's not super pretty, honestly. What you would do is this forever if that actually makes him move, what we would want to do, only make him move if we press the button and he's not touching the color red. So that's kind of the basics of actually making a game. We've now got a background that we try to operate. We're keeping score. We've got a bad guy and a good guy. For attaching the analog inputs, if you go to learn.sparkfun.com, we've actually got something called Driving to Scratchville that goes over how you make what's called a voltage divider and plug in some analog sensors here. So you can check that out. We're not going to go into it today. But I'd like to note that, that while Scratch is an introductory tool, it is an amazing introductory tool, and it's great for people of all ages. It's highly supported by MIT. As well as the whole open source community and anybody that's involved on their Scratch website. So it is a great place for absolutely anybody to start. And I highly encourage you guys to play around. I'm going to show you some examples real quick that you can use to learn even more about Scratch. So obviously I'm going to go in and I'm going to save this. I'm going to save this as number 3. And obviously, my hit test for my walls is not done, so I'm going to come back to this and work on it more. But I'm done for today. And so if I want to go into Files and open a new project, I can actually go over to Examples on the left. There's a whole bunch of examples that actually teach you about a whole bunch of different aspects. So people use these to create simulations, animations, games, greeting cards. Actually, kids do presentations with these. And then you've also got a section about sensors and motors. So this is where you can come for more projects all about sensors and connecting things to Scratch and making that kind of stuff happen. So I hope you guys have lots of fun playing with Scratch. And You know, if you make any absolutely amazing Scratch games, send them to education@sparkfun.com or send us an email and let us know that you did something amazing using your Pico board and Scratch. And who knows, we may host your code on learn.sparkfun.com. So thanks for coming, guys, and I hope you have fun in the world of Scratch.